Hello friends, in the present video, we will see if your water table is rises to ground surface. How much the decrease in the bearing capacity. Okay, for that, let us consider or let us write the bearing capacity equation. Suppose if I write the bearing capacity equation for the continuous footing, okay, let me increase the size. How much I'll get? Ultimate bearing capacity that I can written as CNC plus gamma into D into N cube plus half into D into gamma into N gamma, isn't it? Let us say first we are talking about the purely cohesionless soils. Okay, we'll see one by one. If it is purely cohesionless soils, so whatever the C value will be equal to 0. Then your equation of ultimate bearing capacity that will be equal to gamma into D N cube plus half into B into gamma N gamma. Okay. Now let us consider this is your footing and let us assume this is the ground surface level. If your water table reaches here, let us say in the first case there is no water table at all. Okay. Then your ultimate bearing capacity for the cohesion less soils is this much. In the next case, let us say if your water table is rises to ground surface. So this is when no water table. Now, if your water table rises to here, then what is the equation you have to use here? Your ultimate bearing capacity will be equal to, as the entire soil is under submerged condition, you have to take the effective parameters. So if you use the effective parameter, how much you will get? Gamma dash D into N cube plus half into B into gamma dash into N gamma. This is when water table at the rate ground surface. If you see the difference between these two, what is the difference from here? Here we are considering the dry unit weight. Here we are considering the submerged unit weight. So in most of the cases, it is observed that your gamma dash that will be nothing but a half of the gamma. If you substitute this relation there, so what about your ultimate bearing capacity? That will be equal to, in both the terms I can take off common. So what is the remaining equation? Gamma D N Q plus half into gamma B and gamma. So this is when water table at the rate ground surface. If water table is not there, what is the relation? Gamma D N Q plus half into B gamma N gamma. If water table is rises to the ground surface. Now see, this is what nothing but a ultimate bearing capacity when no water table. So what we can say, if your water table is rises to ground surface, so what is your bearing capacity? That will be nothing but a half of when there is no water table. That means what we can say, if water table rises to ground surface, if water table rises to ground surface, then ultimate bearing capacity will decrease by how much? Ultimate bearing capacity will decrease by 50%. In which type of soils? In cohesionless soils. This is very, very important. This is not applicable for all the soils. This is only applicable for the cohesionless soils. Why? Because we have considered the term C is equal to 0. So if there is a cohesionless soil and if your water table rises to ground surface, your bearing capacity of the foundation will decrease by 50%. So they can ask you like the one more question. Okay, next. Consider the corrosive soils. if you are considering cohesive soil. Now, what about the ultimate bearing capacity? That can be written as CNC plus normal, I am writing just normal equation, gamma D NQ plus half into B into gamma into N gamma. If it is a cohesive soil, what about N gamma value? 0, NQ value 1, NC value 5.7. So what about your ultimate bearing capacity if it is a purely cohesive soil? That will be nothing but a 5.7 C plus gamma into D, isn't it? Now, what about the net bearing capacity? That can be written as 5.7 into C plus gamma into D minus gamma into D. That will be coming as how much? 5.7 into C. So, net ultimate bearing capacity, that will be equal to 5.7 C. If you see here in this equation, is there any term weight density? No, right? Wherever maybe your water table, as your gamma is not there in this equation, so first water table will affect in which one? Submerged unit weight. Wherever there is a water table, you have to take the submerged unit weight. But here, is there any term related to weight density? No. That means wherever your water table is there, net ultimate bearing capacity in cohesive soils will not change. Okay. So what can we conclude from this equation? We can say that water table level will not affect the which bearing capacity. It is not ultimate bearing capacity. It is the water table will not affect the net ultimate bearing capacity of cohesive soil. I'll say purely cohesive soil. Sir, what if your soil is not cohesionless, not if clay soils? If you are having both phi and psi properties, then what will happen if your water table rises to ground surface? If it is a cohesive nature, it will not affect. If it is a cohesionless soil, the effect may be 50%. Let me write it. If it is cohesive, simply I'll say instead of writing cohesive and non-cohesion, let's say that is what important. Okay, cohesion soil, non-cohesion. If there is cohesive soil, water table will not affect. Water table at the rate ground surface, it will affect 0%. If it is a non-cohesive soil, how much it will affect? 50%. If it is both combination of cohesive and non-cohesive, the value may be in between 0 to 50%. It will not cross 50% or it may not be 0%. It may be in between 0 to 50%. Okay. So this is what the effect of water table if it rises to ground surface in cohesive soil, non-cohesive soil and also combination of C5 soils. Thank you.